Meta has released SAM2. This is their next generation of meta segment anything model for videos and images. What can this model do? This model can segment any object in any video or image with prompts. Now your prompts could be boxes, the prompts could be points, the prompts could be mass, the prompts could be text, right? So now based on the prompts, it can do object segmentation in any video or image, even for objects and visual domains it has not seen previously. So this is like zero shot learning over here. And SAM2 has many modern potential, many potential real world applications. Like for example, you can take the outputs of SAM2 with the generative video model to create new video effects. Okay, and unlock new creative applications. It can be used for surveillance, it can be used for object tracking, a lot of things, right? So here is an example which they show over here of a person on a skateboard. Right now the person can be segmented basically, and as he moves around you can apply these visual effects. So this is a quite cool demo. So they have a demo page. This model has been released under Apache 2.0 license, so anyone can use it to build their own experiences. They're also releasing the data set for you to further fine tune a model, right? The weights as well as the code has been released. They have a demo. Let's quickly go to the demo and then come back. So in the demo you can actually they say that you need to select an object by clicking. So for example, it says that not what you expected, add a few more clicks. Okay, the object has been selected basically. I will select the person as well as the ball, right? And now let's track. Let's say track objects. And if you see, as the video moves through, you can actually track basically the person as well as the ball, both are being tracked, right? So they say that you can fix tracking issues by going back to the frames where it is tracking not quite and adding or removing clicks. The kind of works over here, and I'll say next over here. And now I can do overlays, I can do emoji. Okay, now let me see what happens if I do emoji over here. Okay, so it overlays an emoji over the whole person over here, but instead of what if I say pixelate, if you see over here it masks the objects over here, right? It kind of pixelates the objects. Spotlight, okay, puts a spotlight on the tracked objects. So these are the various effects which they are showing over here. Probably if I say that the background, okay, so let me erase the background and let me remove the spotlight. Okay, I don't want spotlight. Okay, these are the various spotlight options are available. I'll go back to original. Yeah, so here you can erase the background. Now you can apply some effects on the background as well over here by changing the background, right? So a lot of options are available over here. So you can check out this demo. What happens if I go to next? Okay, I can download this image basically. I can try other images. I can go to gallery. Various other examples are present over here. Okay, maybe I'll have a quick look at this as well. Seems to be an interesting video. And here let me track the bird. Okay, yeah, and let me track it. Let's see how it works. Okay, here there are multiple birds as well, right, in the video, but yeah, it tracks this bird properly, right? So this is their quick demo. They have their code examples over here in their GitHub page where they talk about how to automatically generate object masks with SAM, right? Then they talk about here is a segmentation of whereby you want to segment automatically generate masks for the objects present in the images. They have some examples of image predictor as well, and since SAM2 can efficiently process masks for the entire image can be generated, so this is an image predictor. So they have the code over here, right? You can select objects and then you can predict the mass of the objects and other things over here. You also have a video predictor example over here. It's just loading. Let's wait for it to load. Okay, so this notebook shows how to use SAM2 for interactive segmentation in videos, the demo which we have seen previously, right? Adding clicks on a frame and to get refined masklet. So there is this term called masklet which is about spatio-temporal mask, propagating clicks to get masklets throughout the video segment and tracking multiple objects at the same time. So you can go and check out the code. Now let's go back to the blog and let's see a little bit more about, how this model was developed and things like that, right? So what they say over here is that with SAM2, you can actually, seamlessly you power use cases across image and video data. Okay. So how was SAM2 built, right? So what they say is that an image can be considered as a very short video with a single frame. Okay. So the only difference in handling video is that model needs to rely on memory to recall previously processed information for that video in order to accurately segment an object at the current timestamp. So what happens in a video is that when you select a reference frame and an object in a reference frame, and as you go through further frames, the objects can be, there could be object motion, there could be deformation, there could be occlusion, there could be lighting changes, right? There could be occlusion and other factors which can drastically change from frame to frame. Okay. So compared to segmentation in images, these are the significant challenges in videos. Other thing is that videos are could be lower quality. They could have camera motion, blur, lower resolution, adding to the difficulty, right? So this is where video segmentation models and data sets have fallen short in providing a comparable segment anything capability for video. So for this, they created their new data set called SAV dataset, okay, to build SAM2. So what they do over here is that for promptable visual segmentation, what they do is that original SAM segment anything model was trained to take input prompts like masks, points or box, right, with an input as an image, right? You have this mask decoder, prompt encoder architecture, and the inputs were mask, points, box, and you used to get the outputs, which is your mask, right? Now what they have introduced over here is that they are introducing a something called as a memory encoder. Okay, what this does is that it creates something called as a memory bank to track, and then there is memory attention to track the object across frames of a video. That is the idea over here. Okay, so what they are saying is that they have designed a promptable visual segmentation task that generalizes the image segmentation task to the video domain. The original SAM was trained to take as input points, boxes or masks in an image to define the target object and predict a segmentation mask. With SAM2, they train it to take input prompts in a frame of a video to define the spatio-temporal mask, the masklet to be predicted. It makes an immediate prediction of the mask on the current frame based on the input prompt and temporarily propagates it to generate the masklet of the target object across all video frames. Once an initial masklet has been predicted, it can be iteratively refined by providing additional prompts to SAM2 in any frame. This can be repeated as many times as required until the desired masklet is obtained. So that is the idea over here. Okay. The SAM2 architecture can be seen as a generalization of SAM from the image to the video domain. SAM2 can be prompted by clicks, bounding boxes or masks. Okay, I had mentioned text earlier, so that's not true. It is actually clicks, bounding boxes or masks to define the object in a given frame. Lightweight mask and decoder takes an image embedding for the current frame, encoded prompts to output a segmentation mask for the frame. In a video setting, SAM2 propagates this mask prediction to all video frames to generate a masklet. Okay, so to do this predict mask accurately across all video frames, they are introducing a memory mechanism which consists of a memory encoder, a memory bank and a memory attention module. So when applied to images, these memory components are empty and the model behaves like SAM. For video, the memory components enable storing information about the object and previous user interactions in that session, allowing SAM2 to generate masklet predictions throughout the video. That is the idea over here. Okay. So memories of the frames are created by the memory encoder based on the current mask prediction and placed in the memory bank for use in segmenting subsequent frames. The memory bank consists of both memories from previous frames and prompted frames. The memory attention operation takes the per frame embedding from the image encoder and conditions it to the memory bank to produce an embedding that is then passed to the mask decoder to generate mask prediction for that frame. So this is the idea over here. Okay, so how you can how are they propagating the mask of the object across the frames? So that is how this memory encoder and the memory bank and memory attention comes into the picture. Okay, so yeah, so that is what they are saying over here. Further details are present over here. You can check out more about their data set and other things. And they have some examples of what you call outputs over here. You can check out it. So SAM2 performs significantly outperforms previous approaches on interactive video segmentation across 17 zero shot video datasets. Okay, so this is about the key highlights. They say that it outperforms on 23 dataset zero shot benchmark SUD while being 6 times faster, 3 times faster, fewer than human in loop interactions. Okay, so this is about the results. What I'm more excited about is the use cases, right? And trying to play around with the demo or the notebooks to see what we can do with SAM2. There are some issues with SAM2. So SAM2 predictions can miss fine details in fast moving objects. So that is what they say. Then they say that if you have multiple objects in this thing, it can miss it. So SAM2 can sometimes confuse multiple similar looking objects in crowded scenes. Okay, so that's also possible. So there are also some drawbacks of SAM2. So you can check out SAM2. You can download the model from their GitHub. You can try out their notebooks. Okay, you can also try out the demo. So this was a short video about SAM2 from Meta. So their new computer vision model for both images and videos. Their segment anything model for videos and images. I hope this video is useful to you. I will share all the links in the description of the video. Do check out.